Electrolysis is the process of breaking an electrolyte by passing an electric current through it. Now, what is current and what is an electrolyte? Current is either the flow of electrons or the flow of ions. In electrolysis, current is the flow of ions. Electrolyte is a compound that decomposes into its ion when an electric current is passed through it. Examples of electrolytes are ionic compounds in aqueous or molten form, acids, alkalis, aqueous copper 2 sulfate, and tap water. Strong electrolytes are those compounds that decompose or ionize completely in their aqueous solution. For example, all soluble ionic salts, all group 1 and some group 2 metal hydroxides in aqueous form, strong halo acids, strong oxo acids, aqueous copper 2 sulfate, and tap water. Weak electrolytes are those compounds that decompose or ionize partially in their aqueous solution. These are weak bases, weak acids. Non-electrolytes are those compounds that do not decompose when electric current is passed through them, as they do not conduct electricity. Examples are sugar solution, distilled water, most organic compounds except organic acids, and petroleum products. Electrodes are rods that conduct electricity. Active electrodes are those electrodes that take part in electrolysis and dissolve in the electrolyte. Inert electrodes are those that do not dissolve during electrolysis. Inert electrodes are graphite or carbon and platinum. Active electrodes are all electrodes except graphite and platinum. The anode is the electrode that is connected to the positive terminal of the battery. The cathode is the electrode that is connected to the negative terminal of the battery. At the anode, oxidation takes place, and at the cathode, reduction takes place. At the anode, positive ions are oxidized, and at the cathode, negative ions are reduced. In electrolysis, the battery pulls electrons from the anode and pushes them towards the cathode. At the cathode, electrons are pulled from the anode and pushed towards the cathode. So over here, the electrons are evenly distributed. The anode becomes positively charged as there is a deficiency of electrons. Therefore, negative ions are attracted towards the anode and positive ions are attracted towards the cathode. And here, the negative ions will lose electrons, and over here, the positive ions will gain electrons. Now, electrolysis can be of molten or aqueous compounds. First, taking molten compounds, so for example, lead iodide, liquid as it is molten. On passing an electric current, it will decompose into Pb2+ and iodide ion. The lead ion, the iodide ion, moves towards the anode. At the anode, the iodide ion loses electrons. To produce iodine plus 2 electrons. This is liquid, and iodine over here will form a gas. At the cathode, lead ions will gain electrons and form lead. These are both liquid. Now at the anode, iodine being sublime will form purple vapors, and at the cathode, lead being a grey liquid will form a grey solution. To write the overall equation of this electrolysis, we'll cancel out the electrons. Write the positive ion first, Pb2 plus the negative ion, lead liquid plus iodine gas. So this is the overall equation. Now taking aluminium oxide, this will decompose on passing an electric current into Al3 plus and O2 minus. The oxide ion is attracted towards the anode. Here it loses its electrons. To form oxygen plus 2 electrons, 4 electrons. This is liquid, this is gas. Cathode, aluminium gains electrons to form aluminium ion, gains electrons to form aluminium. This is liquid, this is also liquid. To balance this, we'll have to have equal electrons in both the equations. So multiply this by 3. 6, 3. Multiply this by 4. Now electrons will get cancelled out for the overall equation. First write the positive ion. 4. Now oxygen being a gas will produce colorless bubbles of colorless odorless gas, and aluminium will form a silver deposit or a silver solution. Now over here, if we're using graphite electrodes, then the oxygen gas that is produced reacts with carbon in the presence of heat since it is molten. So at the anode there is a side equation. Oxygen produced reacts with carbon to form carbon dioxide. Now carbon dioxide escapes, the graphite anode corrodes and it has to be replaced periodically. Electrolysis of aqueous solutions occurs according to the reactivity series or the electrochemical series. For metals, the series is now over here. Potassium is the most reactive and platinum is the least reactive. So during electrolysis of aqueous solutions, the least reactive metal discharges first. Now why is this so? The most reactive metal, reactivity means that potassium will lose electrons most readily and form compounds, while platinum will lose electrons less readily and will remain an element. So platinum has more of the ability to form an atom than potassium, being less reactive. Platinum, being less reactive, easily gains electrons. For this we can take the example that in the first group of the periodic table there is lithium and sodium. Now the electronic structure of lithium is like there are two shells. The first shell is full and the second shell has only one electron, while in sodium there are three shells. The first two shells are full and the third shell has only one electron. Now over here, sodium is more reactive because it can easily lose its one electron, valence electron, because this electron is further away from the nucleus than in lithium. So if sodium forms an ion, sodium becomes positive, lithium forms an ion, lithium becomes positive. Now for lithium, which is less reactive, it is more easy to gain electrons and form atoms because the force of attraction of the nucleus is stronger. So that's why the least reactive metal will form atoms more easily. In non-metals, sulfate, carbonate, nitrate and phosphate do not discharge during electrolysis. Now those ions that discharge are fluorine, chlorine, bromine, iodine and hydroxide ion. In dilute solutions, the concentration of hydroxide ion is the highest. So in dilute solutions, hydroxide ion discharges first and fluoride ion discharges last. While in concentrated solutions, the concentration of fluoride ion is higher than hydroxide. Therefore, fluoride ion would discharge first and hydroxide ion would discharge last. This is dilute and this is concentrated. However, there is one exception, that if the aqueous solution contains a chloride ion, whether it be dilute or concentrated, the chloride ion will discharge first because compounds of chloride ionize ionize more than hydroxide than water, and the concentration of chloride is greater than hydroxide. In the electrolysis of aqueous compounds, the first example we'll take is NaCl, sodium chloride. So now we'll have two compounds in our solution. One will be sodium chloride and one will be water. Now when they ionize, we'll get sodium ion and chloride ion, and hydrogen ion and hydroxide ion. Now sodium and hydrogen both will move towards the cathode, while chlorine and hydroxide both will move towards the anode. However, according to the reactivity series, hydrogen is lower than sodium in the reactivity series, so hydrogen will discharge first. And for chloride and hydroxide, as we know that whenever chloride is in an aqueous compound, it always discharges first. So at the anode, the chloride ion will form chlorine plus 2 electrons, while at the cathode hydrogen will be reduced to hydrogen ion will be reduced to hydrogen. Now the observation over here will be that at the anode a yellowish green gas is produced, while at the cathode there are bubbles of a colorless odorless gas, that is hydrogen. As from the compound contained NaCl and H2O. Now there was sodium ion, chloride ion, hydrogen ion and hydroxide ion. Now since the concentration of chloride ion and hydrogen ion decreases, the concentration of sodium ion and hydroxide ion increases. Therefore sodium hydroxide is produced and the pH of the solution increases. For the electrolysis of dilute sulfuric acid, that is aqueous, the ions in the solution will be H positive, SO4 negative, and from water H positive and OH negative. Now H positive ions go towards the cathode, sulfate and hydroxide ions move towards the anode. As we learned earlier, sulfate ions do not decompose or discharge during electrolysis. So hydrogen ions and hydroxide ions will decompose. Now at the anode we'll have hydroxide. 4 hydroxide ions will form oxygen, hydrogen and 4 electrons. Oxygen, water and 4 electrons. At the cathode, 2 hydrogen ions will be reduced to hydrogen. Now here the observation will be that at the anode bubbles of colorless odorless gas are produced, that is oxygen, and at the cathode again bubbles of colorless odorless gas are produced, that is hydrogen. For the overall equation, we'll have to have 4 electrons to balance it, so multiply this with 2, 2s are 4, Now if we, this 4H plus and 4OH minus can be written as 4H2O, and this 2H2O can be brought on this side, forming minus 2H2O, producing 2H2 plus O2. This can also be written as 2H2O producing 2H2 plus O2. So in this electrolysis, 2 water molecules are broken into 2 hydrogen molecules and 1 oxygen molecule. Now this equation is the same for the electrolysis of all oxo acids. Oxo acids are sulfuric acid, nitric acid, phosphoric acid, and carbonic acid. Now as these have ions sulfate, phosphate, nitrate, and carbonate which do not decompose, always hydroxide and hydrogen will be decomposed, and this will be the overall equation. Now in MCQs we get this question. The diagram shows the results of an electrolysis experiment using inert electrodes. Now since hydrogen and oxygen are produced in the proportion 2:1, and over here this is the negative electrode, over here hydrogen, this is the cathode, over here hydrogen is produced, and this is the anode, over here oxygen is produced, and they are in the ratio 2:1 approximately. So the answer will be answer will be C, dilute sulfuric acid. Next we'll do the electrolysis of copper 2 sulfate using graphite electrodes and also by using copper electrodes. Now when graphite electrodes are used, we have 2 compounds breaking both copper 2 plus and sulfate 2 minus, and over here H plus and OH minus. Now we are using graphite anodes right now. Graphite electrodes. So at the anode, hydroxide and sulfate ions will move. Sulfate ions are not discharged in electrolysis, so hydroxide ion will be discharged. So 4OH minus O2 plus 2H2O plus 4 electrons. Now at the cathode, both hydrogen and copper ions will move. In this case, the copper ion will discharge because copper is lower than hydrogen in the reactivity series. So copper 2 plus 2 electrons produces copper. To balance it, we'll multiply this with 2. Electrons get cancelled. Now for the overall equation, 2 copper ions plus 4 hydroxide ions produce 2 copper plus oxygen plus water plus oxygen. These are aqueous. This is solid, this is liquid, and this is gas. Now in this case, the observations: at the anode, bubbles of colorless odorless gas are produced, which is oxygen. At the cathode, copper atom, a pink mass is formed, that is copper. So showing this diagrammatically, these are the ions present. Sulfate and hydroxide move towards the anode, copper and hydrogen move towards the cathode. Now over here, the battery pulls electrons from the anode, pushes them towards the cathode. Over here we have negative charges. These negative electrons are transferred to the copper ions. The copper ions therefore form copper atoms over here, and there is a mass formed. This mass is pink in color because copper in its pure form is pink. Now from the solution, copper ions are being reduced. That is why the solution, which was originally blue due to the color of copper, 2 plus ion, the solution now gets decolorized. Now for electrolysis of copper to sulfate using copper electrodes. This is also called electro refining. In this case, the anode is impure copper and the cathode is pure copper. The electrolyte is copper to sulfate, aqueous. Now what happens at the anode? At the anode, the battery pulls the electrons from the anode. Therefore, the copper atoms that were over here lose electrons, and those electrons are transferred to the cathode. So these copper atoms form ions and jump into the solution. Therefore, the anode dissolves. Now these copper ions enter the electrolyte, and the electrolyte originally had copper 2 plus ions, hydrogen ions, hydroxide ions, and sulfate ions. Now the copper ions from the solution go towards the cathode. The cathode has electrons on its surface. These electrons are transferred to the copper ions. The copper ions form atoms and collect on the cathode as a pink mass. Therefore, the equations for the anode: at the anode, copper was forming ions. So copper is forming copper 2 plus 2 electrons. This is solid and this is aqueous. While at the cathode, copper ions form copper atoms. Now over here, the copper ions are forming atoms, but copper ions are also being obtained in the electrolyte from the anode. Therefore, the concentration of copper ions in the electrolyte remains same or constant, which is why the color of the electrolyte remains blue and does not fade. The mass formed at the cathode is pure copper in pink in color, and from the anode, which was impure copper, which had some impurities, so those impurities collect at the bottom as anodic mud. Now these contain gold, silver and platinum, and the anode dissolves and has to be replaced.